Okay, 3.4 now, linear programming. Okay, so we got to go over some definitions here first. Optimization.
Nacho, man. I want to be a nacho man.
Optimization is finding the maximum or minimum quantities is what optimization is. So linear programming, figuring out exactly what that is finding the max and the min of a linear function. Okay, so basically we're doing what we just did in 3.3. We're graphing and shading those inequalities, but now not only are we just doing that, we are finding out what the max and the min point is. What's the maximum amount that'll make that item work, and what's the minimum value that will make that item work.
Kids, you tried your best, and you failed miserably. The lesson is, never try.
So the objective function is the main objective of the function. Okay, it's the main idea. So the concept is after you find the max and min, that's what you're trying to use. You're plugging that into that objective function to find out what your answer is. The function is used to actually physically solve the problem by the end. And you have constraints. Constraints are like your inequalities that we just did, that we in 3.3 when you graph the lines and you shaded. Those are the constraints that make up your objective functions.
All my life I've been an obese man trapped inside a fat man's body.
Constraints. Constraints are a system of inequalities used to guide you to a solution for the objective function. Those are the inequalities. That is 3.3. The constraints, what you did, all this stuff we just did in the last section. This is basically 3.3. Linear programming is graphing systems of linear inequalities. You're just finding the max and min as well of it. That's it. That's the only difference. So, optimal solutions of linear programming. Bounded means it's closed in. See something like that? It's closed in. There it is, right? It's closed in, so it is bounded. Unbounded is something like this. See how it kind of goes off in the bottom left corner forever, basically? There is no end in sight. It ends up here, but this is bounded the whole way around, and this is not. That's the difference between bounded and unbounded in linear programming.
They're dogs, and they're playing poker.
So example 1, find the minimum and maximum values. So objective, I'm giving you the objective function, which is c equals 3x plus 4y. And there are your constraints. So we'll start off with something nice and simple. So we want to graph these lines, but first let's solve this and make it equal y so it's easier to graph. So since a positive x, I subtract x on both sides. So I get y is less than or equal to negative x plus 8. So when I go to solve this, x is greater than or equal to 0, right down there. Straight line, right down the center. And pick a point not in the line like 1, 1. Is 1 greater than 0? You betcha. So that's why I'm shading everything to the right. Y is greater than 0. So I go and graph that line. And we plug in a point not on that line like 1, 1. And when I plug it in, that's true, right? That means I shade towards that point. So this whole top quadrant right now is the correct answer. And then now to graph this, my y-intercept is 8. So 1, 2, 3, 4, 5, 6, 7, 8 way up here. And I go down 1, right 1, down 1, right 1, down 1, right 1. And I keep going and draw a line and I connect it. And I need to shade that now. So a point not in that line is 0, 0. Is 0 less than 8? Yes, it is. So in this triangle is my answer. Now, to find the answer, I need to find the max. And to do that, I find the bounded areas is what I'm looking for. I look at the 3 points of intersection where everything is bounded. That point up here, that point is 0, 8. That point down here, that point is 8, 0. And that point there is 0, 0. So I need to take those 3, they're like my solutions, and see which ones give me the max and which ones give me the min. And I plug those answers in to my objective function. So I plug them in. I plug in 0, 0. When I plug in 0, I get 0 as my answer. Now I'm plugging in 0, 8. When I plug in 0, 8, right, for x and y, I get 32 as my answer. And when I plug in 8, 0, I get 24 as my answer. So my question to you is, which one of those is my minimum answer? Well, very simply put, 0, 0, because it's the smallest number. So if I asked you for the minimum of this problem, you would say 0, 0, because that's the min. The maximum, if you were to guess, would be 32, because 32 is the biggest number. So that means when you plug in this point 0, 8, that gives you the highest value. So this is your max, and 0, 0 was your min.
There's purple stuff inside. Purple is a fruit.
So when we come back here, we will finish up linear programming. I didn't want to rush here. I just wanted you to see an example with all of those. With all those definitions, you can kind of tie everything together to see kind of what I was talking about there. When we come back here, we'll just have a whole bunch of examples on this, and we'll hopefully try to finish up linear programming.